Hello and welcome to your Week 9 MyStatsLab Problem 1 screencast. In this problem we are to build a confidence interval for the price of gas from a random sample of 40 gas stations. We are given our mean of $2.59, given the standard deviation of 0.32, and our sample size, of course, is 40. So let's go to part A of the problem, where it asks us for a 95% confidence interval for the mean price of gas. So the first step we need to find, in order to find the confidence interval, we need to know the critical value. So we are going to use the Excel function 10v to find this for us. So if you click on a cell and just type in equals 10v, find it here, double click on it, you see that it asks us for probability and degrees of freedom. Now since this is a 95% confidence interval, we can plug that in, and we know the degrees of freedom is n minus 1, 40 minus 1. So let's get rid of this. Nope. And click on where I have already done the function, and you see at the top equals 10v, and then I have 1 minus 0.95 for the 95% confidence interval, and 40 minus 1 for the degrees of freedom. Let that do the calculation for us. We come up with our critical value of 2.0227. Now step 2 of this part of the problem, we need to find the margin of error. This formula is on page 352 in your text, and that's what I use for this calculation right here, where we take B12, which is the critical value that we just calculated, times B5, which is our standard deviation, divided by the square root of D4, which is the 40, or our sample size. So doing this calculation, we get our margin of error to be 0.102. Now that we have that, we can move on to step 3, where we calculate our intervals. So our lower interval will be B4, right here, our mean of 2.59, minus the margin of error, and we get 2.488. The upper part of our interval will be that same mean, B4 plus the margin of error, and we get 2.692. So a 95% confidence interval will be $2.488 up to $2.692. Not too tough using Excel, is it? Let's move on to part B, where they ask us to do the same problem, only using a 90% confidence interval. So we go back to step 1 again. In our 10v, we're going to use 0.9 instead of 0.95, so that we get our 90% confidence interval, still 40 minus 1 for the degrees of freedom, and that gives us our critical value of 0.16489. Now using that, we can calculate our margin of error again, using the 1.6849 times our standard deviation divided by the square root of our n, which is 40, and this time we get 0.085. Now we go back to our lower and upper limits again. So this time it's B4, our mean of 259, minus our margin of error, and we get 2.505. Same thing here, our mean plus that margin of error, and we get 2.675. So a 90% confidence interval will be $2.505 up to $2.675. Now for the last part of this problem, part C, the problem asks us to do a 95% confidence interval, but this time we're going to use a sample of 80 gas stations, still using the same mean and standard deviation. So in this case now, n is 80. So again, step one, we're going to use our 10V, 1 minus 0.95, since it asks for a 95% confidence interval. But this time it's going to be 80 minus 1 for the degrees of freedom, since n is now 80. And we get a critical value of 1.9905. Using that number, calculate our error again, and we get 0.071 using that margin of error with our mean, which is still $2.59. We can calculate the lower limit as 2.519, the upper limit at 2.661, and we can again say a 95% confidence interval using now 80 as our sample size. We get an interval of $2.519 up to $2.661. Okay, there's problem one. Using the confidence intervals and using 10V to calculate our critical value for us. I hope this helps you out, and we'll see you on the next one.